Hi, third grade friends. I'm excited to jump into a new math lesson with you today. So last time I recorded a video for you, we were working on understanding parentheses and how we can tell someone what to solve first in an equation that has multiple factors or add-ins. And today we're going to talk about determining area using smaller rectangles, which seems a little bit different. And you're right, it is. But we're going to see in upcoming lessons how we can connect parentheses to finding area, okay? So let's get started. On our agenda today, our cat friend says, view the agenda, write meow. So let's get to it. We're going to revisit what's area and when would we see this kind of problem in our lives, right? It's important to know why we're doing this math, not just doing math for the sake of doing math. Then we'll watch a Khan Academy video. We will do a guided practice problem. You'll do independent practice. You'll have a choice of activities today. How fun. And you'll do your exit ticket and you'll be done. So what is area? When would we even use this skill? So I want you to think to yourself, think back to the beginning of the year or earlier in our virtual lessons. What do you already know about area? Remember, this is not perimeter. I'm asking you about area. The area of this shape, or any shape, is the amount of space inside the shape. So in this case, everything that is purple in this L-shaped figure is what we would count when we were finding area, okay? Remember, this is not perimeter. Perimeter is the outside of a shape. Area is the inside of a shape. So say that to yourself. Perimeter, outside. Area, inside. Right? If you want to do it with your hands, you could say perimeter, outside. Area, inside, like you're shading in the inside. Okay, so now that we know what area is, when might we need to find the area of a shape like this? There are many different uses. What if you were an architect or you were in construction and you were trying to find out the area of a building that you were putting together, right? That's really important. If an architect doesn't find the area of the building first, it might not fit on that city block, right? What about a painting? Not like a painting for art, but what if I was painting like a wall, right? I would have to find the area of the wall to make sure that I had enough paint to cover the whole wall. Same with if I was doing tiles on a floor, right? I wouldn't want to run out of tiles. Then I'd only have half the floor tiled. What if you were baking? I've been watching this TV show about this baker who makes these big cakes for people's birthdays and other events. And I was thinking to myself, well, he's got to find the area first, because if he doesn't find the area, then he won't know if the cake fits in his truck and he won't be able to deliver it to the party. What if you were buying furniture, right? Like, what if you were buying a couch that looked like this, right? You'd have to make sure that you found the area first to make sure that it fits in your living room or that it even fits through the door. If you can think of other ways that you might use this skill of finding the area of a shape that looked like this, I want you to put them in either the class comments or a private comment. Your teachers and I would love to see what you come up with. Okay, so now we're going to watch a video to help us understand how we can break down shapes into smaller rectangles to help us find the area.
Each small square in the diagram has a side length of 1 centimeter. So what is the area of the figure? So we have this figure down here in blue, and we want to know its area. Area is the total space it covers. And we're also told that each of these little squares has a side length of 1 centimeter. So that means each of these squares is 1 square centimeter. So we can find the area by seeing how many square centimeters does this figure cover. One way would be just to try to draw the little square centimeters and count them. There's 1 square centimeter, there's 2, and so on, and keep counting them all the way through. Or what we could do is we could look at this and try to break it into 2 shapes.
Which of those methods sounds more efficient to you? Counting up each of the individual squares, or breaking this up into 2 rectangles? Remember, efficient means which one will help us figure this out quickly and correctly. If you said splitting this up into 2 rectangles, you're right. We already know how to find the area of rectangles efficiently, right? Good mathematicians and students are always looking for ways to be as efficient as possible, okay? So do you remember how to find the area of rectangles efficiently? Let's keep watching and we'll find out.
So we can say down here, into 2 rectangles. Down here we have 1 rectangle, and up here we have a second rectangle. And then we can find the area of each rectangle and add it together to find the total area that the figure covers. Down here on the bottom we have 2 rows of unit squares, and each of those has 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. So there's 2 rows of 7 unit squares, or 7 square centimeters.
So there, she just found the length and the, what other dimension goes with length? What's this 7? It's the width, right? We have to multiply the length times the width to find the area of the rectangle efficiently.
Bottom rectangle is made up of 14 square centimeters. It covers 14 square centimeters. And the top rectangle, let's see, we have 1 row, 2, 3, 4, 5 rows. And each of those rows has 2 square centimeters. So we have 5 rows of 2 square centimeters, or 10.
Now that she found the length and the width of that rectangle, I want you to remember something really important. Length goes this way. Width goes this way. I want you to try it with me. Get your hands ready. Length, width. Length, width. I like how she made the length the first factor and the width the second factor, right? Because it's length times width, right? This helps us to know what each factor means. So I know that when I look at this multiplication equation, that first factor, that's the length. And I know that second factor, that's the width, right? It's kind of like when we were multiplying with groups and numbering each, and we always made sure to put groups first so that we would know what that factor meant, okay?
So this top rectangle here that we have in blue covers 10 square centimeters, plus the bottom rectangle that we outlined in green covers 14 square centimeters. So in total, the entire figure covers 24 square centimeters. So 24 square centimeters is our area, because area is how much space does it cover, and we figured out that it covered 24 square centimeters.
I'm really glad that she remembered to label with her units at the end. All right. Now it's time for our guided practice problem. The directions say, in this problem, use the dimensions given to draw rectangle A and B. Then combine rectangles A and B to create rectangle C. Write an equation to represent the area of rectangle C's area. I think what they meant was just to represent rectangle C's area. Let's make that a little clearer. Okay, so I'm going to use the dimensions to draw rectangle A and B. Then I have to combine rectangles A and B to create rectangle C. Then I'm going to write an equation, right? I can't forget to show my work to represent rectangle C's area. Okay, so here, looks like the dimensions I've been given for rectangle A are 3 times 5. So if I remember what I talked about in my last problem in the Khan Academy video, length goes up and down, width goes side to side, and in my equation, the length comes first and the width comes second. Okay, so that means 3 would be going up and down, and 5 would be going across. So let me insert a shape. And we're going to go 3 down, and then 1, 2, 3, 4, 5 across. And there we go. Let's make it a fun color. Make it orange. Okay, so now I have 3 length, 5 width. Same thing for rectangle B, except this time my length going up and down is 4, and my width going across is 5. I'll start up here. 1, 2, 3, 4 down my length, and 1, 2, 3, 4, 5 across for my width. Awesome, and then I'll make it a fun color again. Let's do red for this one. Okay, so now I have rectangle A and rectangle B. I've followed the first direction. Now I have to combine rectangles A and B to create rectangle C. Okay, so combine means to put them together. So let's move over rectangle A. I'm going to adjust it just a little bit because these squares are a teeny tiny bit bigger. So I'm going to adjust it to make sure that it's the right dimension. So 3 by 5. That looks about right. 3 by 5, yep. And then I'm going to add rectangle B to rectangle A, right? I'm going to put them right next to each other to make one bigger rectangle, okay? It looks like what I'm noticing here, once I stretch this out to make sure it's 4 by 5, there we go. Okay. What I notice is that these rectangles have the same width. Look, if I line them up, they both have the same width, right? This one, this red one, is a little bit longer, rectangle B, than rectangle A, but they have the same width. So I'm going to line them up this way, but it wouldn't necessarily matter if I wanted to do it this way. That would be fine too, because I am finding the area of each of these rectangles separately and then putting them together to find the total area. So it doesn't necessarily matter. It's not like I'm changing the length or the width or anything by moving them around on my grid. I just have to make sure that they are next to each other, right? So there we go. I'm going to leave them like that, okay? So when I put them together, I'm just finding, again, the area of each of these rectangles and then putting it together. So let's do that, right? I'm going to scoot these directions over just a bit. Okay, so for rectangle A, my length was 3 and my width was 5. And 3 times 5 is 3, 6, 9, 12, 15, okay? So 15, and it doesn't look like they gave me a label here, so I'm just going to say square units. Remember, area is in square units, or square centimeters, or square inches, whatever the unit might be. Rectangle B, we said 4 for the length, 5 for the width, so 4 times 5 equals 4, 8, 12, 16, 20. 20 square units. Okay, so if the area of this is 15 square units, and if the area of this is 20 square units, what would the area of this whole shape be? Remember in the video how they had to add them together? That was the last step, right? So for rectangle C, which is this whole area, I'm going to put 15 together with 20. And when I put things together in math, I add. So 15 plus 20 is 35 square units. Okay, so I was able to find the area or the inside of rectangle C by finding the individual area of each of these smaller rectangles, and I did that by multiplying the length times the width. Then I added up my two areas that I got to find the total area for rectangle C. All right, friends, now that we've done our guided practice, it's time for you to try an independent practice problem, or a couple of independent practice problems on your own. So you have two choices for the independent practice, okay? So you're going to choose one. You don't have to do both. If you want to do both, that's amazing, but you don't have to. So the first choice is your normal choice. You can go back to today's assignment on Google Classroom. It should be under Math Wednesday, May 20th, 2020. You're going to click on the independent practice determining area using smaller rectangles Google Doc. Don't forget to scroll down, make sure you completed all the problems, and I'm going to add an extra read the directions, right? I've seen some friends who are skipping over sections because they didn't read the directions. If you're confused on the directions, just leave a private comment for your teacher and say, Miss Peglarani, Miss Hill, Miss Fateri, I'm confused on the directions, okay? We'd be more than happy to help you, but don't just skip it if you don't understand the directions. And then you're going to click turn in the top right corner when you're done, or you can wait until you're done with the whole assignment and just turn in the whole assignment on Google Classroom. That works too, probably easier. The other option, instead of doing that, would be to find two rectangular objects in your house, write down the name of each of the objects on a piece of paper, measure the length and width of each object using a ruler that I have attached on today's Google Classroom assignment. You can also use a ruler at home if you have one. Then you're going to write the measurements down, you're going to use those measurements to multiply and find the area of each of your rectangular objects. Then you'll put the two objects next to each other, kind of like I did in the last problem, and you'll use your calculations from the last step where you found the area of each to find the total area of your new shape. And then you'll send your teacher a picture of your work on Dojo or in your Dojo portfolio, okay? So again, you're just choosing one of those. If you want to do both, that's awesome, but you are only required to do one of those, okay? Then, after you've completed one of those activities, you're going to go to do your exit ticket. So you'll go back to today's assignment on Google Classroom. Should be under Wednesday. I forgot to change the day there. May 20th, 2020. You'll click on the exit ticket. You'll complete the activities as usual and click submit at the bottom. And then you'll go back to Google Classroom and click turn in. Okay? That is all for today, folks. If you have any questions, please reach out to your teacher, and I look forward to seeing you soon.